74-year-old company because there are many lessons that you can learn from what happened in the past. And our traditional corporate headquarters look this, a very Gothic building that still stands in London, built about 150 or so years ago. And that building was really not just the height of the new Prudential of what was in the Victorian age, but also, more interestingly, what it was designed to do was, it was designed to keep lots of policies, all the policy data in huge stacks. Those stacks literally ran for what seemed like miles and miles, and they were like rabbit warrens. As you can see this gentleman here, which is a real picture from our rudimentary policy admin system, as you can see it in place here from the last century. But it wasn't just policy data that we kept. But the other thing that we did was we added a lot of people who, in this case, you can see tabulators and people who, with the job title of computers, who were looking at these policy files and reasoning over them and giving insights to our actuaries and help them design better products, help them calculate premiums and so on. But if you think about it, really what was built there 150 years ago is what we would call a data center today. It's lots of storage and lots of compute all in the same place. Of course, that's not all. We also had agents who were the embodiment of our user interface and who would roam the streets like this dapper gentleman here in last century's London, just outside that building actually, looking for customers and looking for serving them. So that really is an interesting backdrop there from my own point of view, in that that is really what we've built 150 years ago. It's really the first incarnation of a data center. But so what's the point of talking about this, especially in this talk here? But really what this enabled us, having storage and compute in the same place, what this enabled us to do was to build something that was called penny policies. Now, it was insurance policies that were for the first time affordable by the emerging middle class of Victorian England. And the agent's job was to collect the premiums, bring the policy documents back into this corporate center, and the computers would then be able to review what are actually our claims, what is actually being paid out, and therefore be able to successively lower our premiums, and therefore make them much more affordable to this huge expanding space that had no financial security up until then. So that's sort of a little bit of history. And so what about now? Well, obviously we still have storage, compute, and user interfaces, only that the data now doesn't sit in stacks of files, but it sits in our own data centers that are nowadays actually in the cloud. We have compute, but the compute has now really morphed to machine learning. And we have a user interface that, of course, is a mobile app. So if you get these things together, you have something that's hopefully a compelling user experience for our existing and new customers. And obviously, following the Silicon Valley mantra, we want to make this user experience as frictionless as possible. But really, obviously, who are the users of this user experience? Our customers, our existing agents, our partners, and really the friends and connections of our customers who we're enticing to join our offering. And all of that really comes down to driving actions. They don't have to be automated, they're ideally automated, but that's what it comes down to. All of these drive actions. And that's really what this whole setup of having data and machine learning in UI, what that is really supposed to deliver is actions. And what we want to do with these actions is we want to understand continuously what did we predict, what did the machine learning algorithm predict would happen, and what did actually happen in the end, and thereby then feed the differential back into our data. So that with every step we learn and with every step we improve, And with every step, we get closer and more intimate to our customers. And again, you could ask yourself, so what? Well, the so what in 2022 is, you know, it's actually very similar. If you may have come across this very famous curve, it's called the Milanovic curve, and it shows the growth incidence by income percentile. And what you can see is the famous 1% over the last 30 or so years have obviously massively increased their wealth, and the people below that in the sort of existing middle class, especially in Europe and in the US, maybe not so much, and that's why we're sort of floating for the crazies. But what's much more interesting is what's happening here, and that is over that period of time, over the period of a couple of decades, we've had this emerging middle class globally in markets that weren't there before. And really our purpose, therefore, in 2022 is from our corporate point of view, the so what here is to try and bring financial security to the emerging middle class in Asia and in Africa. So that really is the basic construct, and I will come to underwriting a couple of times in the course of this talk. But obviously, there's a whole bunch of tasks that are associated with what you want to do. There's something around data engineering and getting all that right, building the pipes. There's something about actually building the machine learning models and deploying them, and there's a lot of MLOps. And then there's building the connection between the machine learning and the rest of the world, which is good old solid software engineering. And by combining all these things, we're trying to build an AI system for underwriting that is fit for the 21st century. And I'm going to give you some hints of that in the course of the talk. One question that as AI practitioners, we should ask ourselves, how do we scale with the number of people? You have sort of an imaginary scale of value that we're creating for our employers. And against that, the number of people that we have to create that value. And naively, you think that could be a linear relationship. That's what you'd probably expect. As you add more people, you add more value. And of course, this is a log-log scale, so the linear is to be taken with a pinch of salt. But in reality, we're not on this naive curve. In reality, we're much more likely in terms of this curve, where over time, as we're adding more people, the value that the incremental AI person creates is actually decreasing. Because we are starting to get middle managers, we're starting to get into organizational processes, we're starting to run into other limitations of scale. Whereas really what we want is we want to be on this top curve here, where we're scaling beyond the limit. So the question really is, how can we deploy AI and scale beyond the linear? And that's what I'm trying to share with you in this talk. At least a couple of very simple, naive viewpoints of how that may be achieved. The first part of this is really the use cases. What are we building AI for? And a lot of us are building AI to run our traditional existing businesses. And some of us who are lucky enough are also in charge of building a new digital business. And those two couldn't be more different from each other. They're very, very separate and very different needs. In the traditional business, they're selling traditional products as we have been for decades through traditional channels. Remember this extremely well-dressed agent, for instance. Whereas in the digital world, we're trying to figure out what are truly digitally native propositions that we can sell, not just insurance products, but what else needs to go into this that we can sell through the emerging digital channels. And of course, in the traditional world, we all know that insurance is not proactively bought. Nobody wakes up wanting to buy insurance, but it is actually actively sold by some intermediary. Whereas in the digital world, hopefully we have an opportunity by addressing the right customer with the right message and the right product at the right moment in time, we stand a chance to break this mantra. And of course, traditional has traditional processes, Whereas in the digital world, we want to use data and AI to replace these traditional processes. So really what we're having is, in the traditional world, we're using AI for incremental change. And whereas in the digital world, we're really trying to reinvent our business using AI. That's much harder. And most of us are bonused on the incremental change, but that's really where the excitement happens. And therefore, the choice of use case is really important. And let me bring that a different view on that. And I really think that the incremental stuff, a lot of it is very much tinkering. Because if you look at different approaches to trying to manage traditional processes, so if you have traditional approaches to driving process improvements like Six Sigma, they really just take sort of one branch of the processes and try and improve on them. You can do a little bit better on that. You can sort of think about automation, and there's lots of people who are trying to entice us to buy RPA solutions, and that could be one thing. That takes big branches of the process and tries to automate them in a wholesale way. Or you try and bring some machine learning to it and you call it intelligent automation. But really, of course, what you're doing is you're just taking the existing traditional process and you're trying to find a way to automate it, to make it smoother, make the traditional process work better. Whereas what we really want to do, and so this, a lot of this also requires very much manual interventions. You set, even the automation piece is set up manually, is maintained manually, tediously maintained manually as processes change, as the environment changes, and so on. Whereas what we actually want to do is we really try and find a way to reinvent those processes and get rid of all these steps. No longer be in a position where we have to just optimize what's already been there. And it's probably not going to be as simplistic as it looks here with just a single straight line. But if we have an opportunity to use machine learning and artificial intelligence to completely reinvent our process, and of course, as you can imagine, this is where all the value is. So choose your use cases wisely. If you want to scale beyond the sort of naive linear curve, choosing the right use cases is pretty crucial. Now let's go back to underwriting, or as I prefer to think about it, no more underwriting. Because underwriting for us still looks like this. We have lots of paper forms. Those forms haven't really changed that much since this gentleman roamed the streets of London. And this is a typical one. It's actually in Thailand, it's the English version of our Thai questionnaire. It has about 58 questions on it. And the questions are things like, have you ever smoked? Now, if you're buying health insurance, what do you think most people will answer to that? There's one of our countries that we're serving in Southeast Asia that I've looked at recently, 92% of the population say they've never smoked. If you actually walk the streets of that country, you will find it's most likely the other way around. 92% of the people you see seem to be smokers. The other thing, of course, is that there's lots of silly questions like this, and some of these conditions are, never mind that they're important. I don't even know how to pronounce this, quite honestly, and some of them sound terrible. But really, is throwing a whole bunch of Latin names of illnesses the best way to capture underwriting data? I suspect it isn't. So if you think about what matters for the for claims like this, what matters in our life insurance installed base, what we found is that there's really 5 things that matter more than anything else, and that's age, BMI, gender, smoking status, and location. Again, this is Thailand data, so we have a lot of traffic accidents. Location is an important feature here. But all of these seem obvious, and you can see from their magnitude, from their future importance, that if we focus on these, we probably capture most of the risk. So what we've tried is, we tried to look around, how can we get these 5 things just from a selfie, and there's obviously lots of established papers out there, And we've applied that to our team. So that's my colleague Marek here, for instance. The age is about correct, and yes, he is male. It's my colleague Philip, Stephen, Arsh. It's not quite so certain whether Arsh is male. I suspect it has something to do with the turban, but I'm not certain. There's Glenn. Glenn also gets it right, but then we're getting to an interesting territory. Now, these age estimations are clearly not right. As much as my colleague Chen here would want me to believe that she is actually 20 years old, this is out by almost a factor of 2. And obviously, as you can imagine, for life insurance, that's a pretty crucial thing. If you underestimate the age, you get everything else wrong. And you can see the same with Jasmine here. Whereas for me, again, the age estimation is correct. Although I do wonder why it thinks that there's a possibility that I'm not male. Maybe it's trying to tell me something I don't yet know. But clearly, there's something going on here. That if you just use the pre-trained model, we're getting this wrong. And therefore, the most important thing that we try to do is get our own training data. So we got about, in Thailand, we got about 9,000 images from about 4,500 people. We went to things like our annual cycling competition. We asked people to volunteer, to step on the scales, have their height measured, have a picture taken. And what you see here is some of my colleagues in Prudential Thailand, female and male, and just out of curiosity, this is our the average Prudential Thailand employee face, the female portion and the male portion. I hope you agree with me. It does look rather beautiful, even though the underlying image data set is made out of normal, just standard normal humans. But so we've built this proprietary tape data set to crack this problem of our models clearly not getting East Asian faces right when we use the pre-trained model. So what we've done is obviously we've put this into action. What we said, we have this feedback loop. So we said we've built our proprietary database. We've thrown neural network at it. We've had a simple user interface where we showed people the data that we thought, and they could tell us whether it's right. And that then fed back into our data, into the labeling of our data. So that's clearly an important thing for us to have, this proprietary data on labeled facial images that will help us make a much better estimate of those top 5 criteria that we were looking at. And we've actually launched this, so this is live. This is not just a silly little prototype that never sees the light of day. That's actually been launched in China. Let's talk about something different. Obviously, AI people, we always like to talk about algorithms. This is a chart I've stolen from this book, which I highly recommend. And it shows the development from the 1930s up until the early 2000s across different kind of approaches of algorithms, from the more numerical to the sort of more categorical up here. And you can see approaches waxing and waning. So, for instance, expert systems in the 1980s were really popular until they turned out to be a dead end. But what's more interesting about this chart is obviously what's not here, and that is that 3 of these have, over the last decade or 2, seen massive growth in adoption. And there are obviously everything around the Bayesian type approaches, especially probabilistic graphical models. Gradient boosting decision trees is clearly an important tool set for all of us, I suspect. And then, of course, there's everything around deep learning and the various derivations of it that we see in practice. So far, so very useless. Picture lots of different algorithms, and some of them become more popular. Versus the actual question that we should ask ourselves is, what algorithm should we use then? And my ready reckoner for that has kind of 2 different axes. One is sort of a volume axis, and the other one is the cost axis. And the cost is not of deploying the algorithm. The cost is of making the wrong decision. So what happens if I do something that actually turns out to be wrong? And if you think about it, take an example. Google has if you Google, run a Google search, you have huge volumes, whatever it is, 3.5 billion Google searches a day. So you're clearly out here on the volume side. And what's the cost of making the wrong, of showing the wrong ad on a Google search? Well, it's clearly minimal. So Google, we would expect to be somewhere down here on this chart. Take another example, look at a hospital and maybe calculating radiation dose for treatment of a cancer patient. And obviously, volumes are much lower, and the cost of making one decision can be pretty high. In the worst case, you kill the patient. So those are two very different extremes, and obviously there's a lot of space in between. As it turns out, those three sets of algorithms that we talked about earlier map quite neatly into the space, because down here, understanding correlation is absolutely good enough, whereas up here, you definitely need some understanding of causation. Because just stating that because Fred and Sue kind of look similar from a data point of view, giving them the same radiation dose, seem to make sense, will not go down so well in your medical malpractice trial. So, and obviously that has implications of what we're going to use. So deep learning is great if you have huge volumes, low cost of getting it wrong. On the other extreme, you need to go through the pain of building probabilistic graphical models, and I've done that now a couple of times, so it's really, it's a painful thing to build and to maintain. And for the most use cases, just in between, this is absolutely good enough. So now we've spoken about what algorithm then. But it's not just that we only choose one algorithm. A lot of the time we think about combinations of algorithms. And you can see that if you think about think back to what is it that's actually intelligence. You could define intelligence naively as how well can you do something, which is sort of the x-axis here, performance, how well can you do a certain thing, how well can you cook a meal, versus how many different things can you do? I can cook a meal, I can maybe conduct an orchestra and go to space. Maybe not, but that's all the things that humans tend to do. And obviously, generality, as we're high up, our models make fewer assumptions and can do more things. And think about where the human falls in this space. So the human falls at this line of 1 and 1. And if you go to the line that equals, if you multiply those two, it equals 1, you get to this kind of human frontier. There's probably something like a realistic frontier where you get very few humans have actually 100 times the performance in a particular task than the average human. But then map onto this a whole bunch of AI kind of success stories, or even the sort of originally comically-looking humanoid robots are making progress. The self-driving cars, the recommendations have made great progress. So that's sort of typical things that we see. Obviously, I've put AlphaGo and AlphaZero in here, which are really interesting cases. And on the other sort of the more pathetic end, I've put the kind of things that we've built in our own company. But if you look at this chart, what you find is there's a couple of very different regimes. And you have one regime which is indicated by this line here, which is essentially trying to solve the problem with effectively a single algorithm. All of these have a combination of algorithms to try and solve that use case. And luckily, our latest approach sits on this line. And then we have sort of the breakout here, which is sort of the AlphaZero type approaches, which sit on a completely new line. So let's look at that. Before, just sort of an aside, if you're a science fiction aficionado, once we reach this line, we're supposedly on artificial general intelligence. Actually, all we really do is narrow intelligence, and who knows whether this super intelligence, Boston super intelligence, will actually ever realize. But of course, our use cases will sit sort of down here at the moment. Let's see how close we get to that. But let's have a closer look at AlphaZero and what happens there, because sorry, and by the way, I forgot I had this on. What I can't fit well on this chart, I appreciate insights and help from you, is all the new stuff, or a lot of the new stuff, but I'm not quite sure whether it actually fits on the chart and how it fits. If you have any ideas, please contact me. My name is fairly easy to find. Would love to hear from you. It does puzzle me. Okay, as promised, let's go to alpha zero. So let's think back at the generality axis and the evolution of alpha zero that has gone through itself. So it obviously started with AlphaGo beating Lee Sedol, and AlphaGo really learned from human games. The next iteration of it didn't require human games anymore. It learned from first principles. It still was very much restricted in use cases, but at least you had to give it just the first principles. Whereas Alpha Zero could do any a two-player perfect information game. And it can learn that from scratch. So how does it do that? So what it does is it runs a couple of different models at the same time. There's two neural networks. There's a policy network that tries to figure out what are sort of essentially the allowed moves. And then there's a value network that tries to figure out, how can I maximize the outcome of my moves. And that's combined through a Monte Carlo pre-search that just looks ahead, looks into the future as to what are potential moves that can be taken. And then what it does, it iterates that a couple of times, or in this case around a couple of 100,000 times. And what we come up with is a whole new training data set with a new policy network and a new value network. And those, the winning ones, you feed back into the original step. And then you go through the loop again and again and again and again, and you do that a lot of times. And what comes out is an algorithm that then can beat humans or existing programs on a whole bunch of things in an amazingly short time. Of course, it also requires us to have this, from the Monte Carlo tree search, to have this massive combinatorial search space available to us. You also need to have some kind of clear objective function, reward function to optimize against. And the third thing that you need is you need lots of labeled data and some kind of efficient simulator so that you can take the view forward as to what it is. So Alpha Zero actually isn't just one neural network, or it's just one single reinforcement learning algorithm. It's actually a very, very clever combination of algorithms. And that's what I'm trying to get to. It's not just about which algorithm you choose, but also which algorithms you combine. And that's just as important as the choice itself. The next thing I want to talk about is what AI systems are we actually building? I want to give you an example. It's an AI engine that we've built in-house at True. We start trying to understand user behavior. So it's a sales engine that's trying to start with user behavior. So we have some kind of behavioral data coming in, and then we have some kind of labels that we associate with certain kinds of behavior. We have actually a couple of thousand labels that we're interested in. And that behavioral data, then we go through a two-step exercise. The first one is automated. The second one is entirely human, clustering and segmentation. So we run a whole bunch of different clustering algorithms to try and figure out what are the different sort of clumps of behavior that we find in our behavioral database. And we then take these clusters and we build a segmentation that then informs a campaign database. So we have a user base and we want to campaign against them. We try and understand the user base in terms of the segments. We pull in the insurance products that we want to sell. We also pull in a propensity model that tries to inform what's the likelihood of a particular user in that database to actually purchase what we're trying to sell them. Now, of course, what we're doing is we're feeding that into a campaign engine, ideally an automated, highly automated A/B testing engine where we automatically pull in the relevant marketing collateral. And that then in turn drives this funnel, where we look at the funnel drop-offs and hopefully you get some dollars at the end. But much more importantly, what we look at by looking at the drop-offs, we can feed those drop-offs back into our propensity model. And our propensity model isn't just about the dollar sign at the end. It tries to predict every single drop-off stage in the funnel. And if you run this a couple of times, I probably to begin with manually, but ideally in a fully automated way, that improves our propensity modeling, our understanding of the customers, therefore, with every single iteration of the campaign engine. So that's what we've built. But what does it mean to say we've built something? Because there's different ways of different levels of maturity of building something. At the most basic level, of course, that's the level that we started. It's just a data science project. There are Jupyter notebooks, snippets of code, snippets of charts. There's no automated APIs. It's all human. That's really the starting point. And if that's all that I had described in the previous page, that would have been very disappointing. The more interesting level of maturity is the next one up, where we start to sort of properly maintain code, pull it together in the right way, test it before we rewrite it, harden the modules, connect them up, but actually still overall have sort of effectively manual control, which takes us to the next level of maturity, where we try and get rid of some of those manual controls, really connect everything by APIs, have this feedback loop running, maybe still semi-manually, but at least everything runs through some proper software engineering. The next level then is to have this feedback loop automated. And that's obviously an absolutely crucial step in the maturity. And then the final one is, if you're a software vendor, you would want to think about how to make it so that you can install and just configure this system anywhere. So the question here really is, what level of maturity are you developing to this? I know that obviously all of us find it really easy. This is the starting point. Most of us probably still cope with bringing it to 2 or 3, but with 3, we're probably always struggling. I know my team and I, we're struggling with this because that's not really our expertise. Our expertise is much more sort of experimenting with things like that. So we have a process of where we hand over to our own internal platform development team that takes the maturity higher. But if you think about how to get from this kind of linear, naive curve of how to get value out of your AI people, pitching towards the right level of maturity is absolutely crucial. And finally, what I want to share with you is actually a mistake I've made for a long time. Because if you think about AI versus humans, and you think about sort of the value that's created by either an AI system or by a human, either when they're in early stages or where they're sort of starting to begin professionals or where they're really, really highly competent professionals, if I versus the value that they create for the company, if I think about sort of something like an actuary, obviously you wouldn't necessarily want to hire an early stage actuary and let them loose on sort of real things. You want to wait until they're actually professionals to get them in. But really, the incremental value of this highly experienced actuary for our business is versus the standard professional. There's obviously some increment, and that's why that line still trends up. But it is not that pronounced. It's not as high as the differential between the professional and the beginner. Versus when I think about our agents, a really, really, really good agent can make all the difference for us. And this is where my lesson comes in. Early on, after I joined Pool, I spent a lot of time thinking about how can I automate what the agent does. But actually, that's not where the value is. That the agent is the person who taps the customer on the back of on the shoulder and says, "Yes, you're doing the right thing. You should buy this policy." And a really good agent can make a huge difference. So another level of that you think about where you apply your AI. What is it that actually delivers value? Don't try and automate that. Automate those things where that curve isn't so steep. So to summarize, there's a couple of things that really you need to do to take AI out of the niche. One is think about the use case, and it's about reinvention versus sort of being incremental. The other one is sort of systems maturity. The next one is proprietary data, what algorithm when and how to combine algorithms. And obviously then there's the value of humans. And most importantly, in all this madness with the latest GPT, whatever, you've got to try and stay sane. Um, so thanks for listening to me. I wish I could be with you in person and answer your questions in person, but I apologize that's not possible. If any questions that you want to direct at me, you can find me quite easily on social media. Please do reach out, and otherwise enjoy the rest of the conference, and hopefully see you at the next rework event.
I mean, it can't hurt to clap. That's fine. I'm going to welcome our panelists up to the stage. Yeah. Yeah. Julia is going to be our moderator. Yeah, Philip and Sajid are coming back up. They were there before. And then we have Eileen Potter from Abby as well. I'm going to hand it over to Julia to do.
So I'll separate the two of you so there's no fighting. You just never can be too, well, you know. Awesome. Reputation is there.
You guys hear me? Yes? Good. Okay. We are all that stands between you guys and happy hour, and I'm guessing a couple of like fried brains out there. Like, please take a little minute, like do this, whatever you need. There's probably like just barely twice as many of you as there are of us, so like shout if you've got a question. I think this is going to be better if it's a conversation. Basically pre-happy hour, happy hour. Yeah?
Yeah, absolutely.
So what she's saying is she'll take the hard questions.
Yeah, sure. Yeah. I mean, you saw my value. It's plateauing as we speak. It's a very harsh slide. So we're here to talk about operationalizing AI. Yes. Basically getting the model out into the world, like getting stuff done. And so I think as a first starting point, like, where do we see the kind of like, I guess maybe let's start with, what does successful operationalization of AI like look like? Maybe Eileen, I'll direct that one to you as the like OG member of this panel.
Well, no, so I'm guessing I'm the least technical person on this panel. I'm all business. And so to me, that's what you need to think about first, is the business side. What are you trying to do? I mean, technology is cool. We can all agree that it's cool. But from my perspective, it's about, so you've got your policy side and you've got your claim side, and what business problems are you trying to solve? You know, everybody's got a big bunch of tangled systems. My background is definitely, you know, started out on the core system side. Of course, I started out with just manual processes, but that's just dating me and aging me. But, you know, thinking about core systems and all this new technology, so what business problems are you trying to solve? That's how you do it. It's not just about the technology and saying, this is so cool. It's about thinking about the business side first.
Yeah, I mean, everything has to start with a business problem, and everything has to be value driven, because at the end result, if it's not getting any value, then why are you doing that? And, you know, the thing I like to harp on the most is, you know, this is three components. You know, this is data, this is MLAI, and this is business. And you could build a model, and you could build a prototype. And with that, you have to curate the data to feed that model. And then you have that model, and that model spitting out results. But remember, 90% of this is data preparation. So that curation you did for that model and that prototype, you got to go back and make that a project as well, because that's the project that's the most important, because that model can change all the time whenever you're going to be pulling in new data or new models are out available for you to use. So in order to, you know, make things work and productionalize them, you have to know the hops that you have to take to get there. And, you know, from going from prototype to production, you know, it's building a railroad to a model, and then that result is also going to come out, jump back on that track into the business process, and solve a problem for you.
Yeah, I realize I fully blew past intros, and since this is not actually going to be the right panel in the program, maybe we'll step back and do that. You guys heard from me before. I'm Julia Romero. I'm the lead for actuarial engineering and advanced models at Haven Tech.
Yeah, I'm Sajjad Abadi. I'm lead ML engineer working at Solar.
So I'm Eileen Potter. So I lead Abby's insurance solutions practice.
I'm Philip Swinner, machine learning engineer. I work with Shazad. And just one thing we like to mention is we're at a startup. So we get to take all the bad problems that the insurance industry has. We get good business leaders that direct us, say, okay, this was the past problem. We couldn't do this at old company B. And now, we have business process and we augment that with ML. So that's the kind of harmony that has to kind of exist.
So maybe, oh, go ahead.
No. So I think that's really interesting. So when I think of it, is that insurance really hasn't changed. So like you've got policy transactions and claims transactions, and those things haven't changed. You still have to underwrite, you have to onboard, you still have to, take in your first notice of loss, and you still have to settle a claim. And you have core systems that do these transactions at this point pretty well. But customers' expectations have changed. There's all these new technologies that can help those systems. I think insurance companies were so used to, it's like, we're going to rip and replace and rip and replace and rip and replace. And I think that COVID really caused a shift because you had all these systems that were doing the transactions. It's like, well, now we can still do the transactions kind of, but there are all these gaps. And then people were like, well, we'll just digitize a process. And it's like, well, you need to, some of the slides here, you shouldn't just take a process and just digitize it. You should reimagine it and think of what's changed.
Yeah,
and
don't say this is what we used to do.
This is what we used to do. So, yeah.
I think that's interesting. You said rip and replace. I think there's kind of an interesting facet to the challenges in operationalizing these types of models across different business lines and applications. I know from the life side, migrating blocks of business around is a huge challenge, and like a thing that people like agonize over. Because on the life side, again, you're having business that's on the books for 30, 40 years. And so you've got systems that like may or may not still need like vacuum tubes.
Well, what you're alluring to is cultural, change in the organization. And one thing that I could say this for every industry. Anything that's being augmented with tech. Well, the business and the tech team have to come together, because if you don't, you might create a us and them, us versus them. Mm-hmm. Oh, the tech people say this, the business guy can't do that. We're a team.
Yeah.
The business has to, they're the impetus for this, and we're all baking the recipe together, and the end product has to have everyone's input, but also, that's the way I see it.
Absolutely.
Yeah. Have you seen instances where like a certain cultural setup has led to like greater potential for success versus not?
If you champion it, and you have people saying this is new. So it's not like, you're coming in an automaton, doing the same thing. Now we have a change happening. And it's like, from my own experience, what my company did was a global personality exam together, where we all knew who we were, who was adverse to change, who was most likely to change, all that. And then, start to build up those relationships. So, we're all kind of Hakuna Matata.
If you think about like problems with developing ML models, like when you're working with a business, is like most of them like, hey, these ML models are gonna take our jobs and it's gonna replace us. Like that's the challenge. Like you need to when you communicate with the business, you need to communicate smartly. Like, you are important, guys. You are like a really important part of building our models, and you're gonna be there. We're not trying to replace you. Our ML models actually is gonna make things easier for you, and it's just going to be more productive and things like that.
Yeah, Eileen, I know you actually work in applying models too.
So definitely, I work on the process side and the content side. But, a point I was going to make about replacing people is that, so you think of insurance transactions, they're simple and complex. And so on the PNC side, if you have an automobile claim and your windshield is broken, well, you can use AI and just get that straight through. Nobody needs like, Eileen, I'm so sorry, your windshield's broken. This is just, it's orange. It's like, you just need your windshield fixed. I don't need someone to show empathy. I just need to know, are they gonna come to me? Do I need to do it to them? That's quick. Well, if you're in a serious auto accident and somebody's injured and your car is totaled, or you've injured someone else, you can use technology to help do those quick things and use, things like intelligent document processing to read documents, so somebody doesn't have to go through, tons of repair invoices and medical invoices. So you can use technology to do that, but you still need that empathy. You still need a person to help you. And I think, that's part of it, is like, talking about agents aren't going away. Like, seeing the end of that, it's like, but what are they doing? Technology is not taking your job, it's making your job easier.
Yeah.
Exactly.
Different in some ways. Different in some
Yeah.
ways. So on the front of technology, in kind of across the board, maybe Sajad, you can speak to this a little bit since you need some airtime. From a tech perspective, like, where have you found success or like hurdles, and particularly like applications, whether it's something that's agent facing or something that's like home office facing, in like actually getting operationalized ML out the door?
Yeah, so basically, like, like building ML models is like, it's really challenging. Like, I read the paper like published 2 years ago. Only 85 or 90, sorry, only 10% or 15% of actual ML model developed go to production. And the reason for that, like, we work on develop models, but not all of them goes to production. The reason for that, most of the models we're developing is not accurate enough to make like a good business value or add money to the product. Things around like, when we develop our models, we need to make sure we have a good data, and we need to make sure like, hey, we're gonna feed them our models with the same data. If we build some transformation, we need to make sure like when we push the model to production, the same data is gonna be there with the transformation. So here it comes about where like when we push the models to production, the models could be perfect for 1 week or 1 month, and then we'll see the models like the score is really far away from the reality. For example, talking about like credit risk model, if you want to like develop a model, so after 1 month you see the data shifting or something happen, your models really start to score like lower and things like that. So we need to build that the ML ops operation. Like, we need to not only just build a model and push it to production, the monitoring and observability, make sure the model is like doing good after the production is something important. So things like that, it's really important to make sure like, hey, the model is successful. You should know when is the right time to retrain the model. Some of the best application in the world, like TikTok, like for example, it's basically they retrain their algorithm in real time. That's why you see it's overtake Facebook, because basically if you look at video for like 5 seconds or 10 seconds, they record all of that, and they take all these metrics, and in real time they train the model, and their recommendation models like understand you, create a file for you. That's why you see like you will see all the content again and again. If you watch sports, you're gonna see all the sports videos and things like that. So that's why like we need to understand, hey, how we should monitor the models and how often we should retrain. We have things like long feedback, short feedback, and that depends in each case we use.
Yeah, I think that's an interesting point about that you made about TikTok and the challenge of feedback, right? Like, TikTok can learn something from you watching a video for 5 seconds, but insurance, that's much more challenging. Um, like, do you guys have thoughts on like best practices for like the feedback loops in that way around the different insurance kind of topics or topologies?
From that aspect, wait, could you repeat that again?
Yeah.
Sorry.
So, in terms of like feedback cycles,
Oh, okay, yeah, yeah. So our human in the loop. So as we have thresholds for as we analyze documents coming in, and as our accuracy would go lower, as it goes through the data flow, we would discard that as an exception, and basically from there we have our kind of BA in the loop, and from there they're going to go ahead and do the correction on that. But essentially that's kind of our feedback loop where we have a human in the loop that it's able to kind of relabel the data, and then we're going to go ahead and retrain. But honestly, I mean, it's just basically, you just kind of have to check the deltas over time.
Uh, I will add and feel like basically in insurance, like I think most of the models currently we have, for example, claims model. Like say, if I build a model and basically the model is going to predict a claim, hey, it's like, the model is basically write a policy for this person on this person, like file a claim within 2 or 3 months. This thing we call it like long feedback. So we don't have short feedback unless we push like a recommendation system like TikTok, Netflix, Amazon. It's basically, hey, okay, I push this product and you access this product.
we have long
When
feedback
insurance,
and longer
we have long feedback.
Yeah.
It's similar to fintech. Like when you're working with a credit risk model, you see, hey, if this customer is gonna default after 3 months, so you're gonna bring all that feedback and retrain the model. Then your model is gonna be smart enough again to understand, hey, oh, what should I do? And things. Yeah.
Yeah. With that long feedback gap, model monitoring is increasingly important. There's regulatory pressure around this. How have you guys found success, or where have you found challenges in implementing like robust model monitoring? And maybe I'll point that at you.
So I don't know that that's really my strong suit here. Like, so when I look at really when I think of operationalizing AI in insurance, I'm looking at the big picture, like overall all of the processes that you're trying to do. And I think that one of the biggest challenges is that people aren't looking at things holistically before they're inserting some kind of technology or a model here. They're just like, I think it might work here, or I think it might work there. And you and I were talking about this because you're an actuary by training. And so I always think about if you're going to put technology into a process, if you're going to change it based on a model, you need to understand first how your processes are really working today. And you shouldn't do that based on a hunch. I mean, it's like, yeah, I think it might be here. And your hunch might be right, or it might give you a good starting point. But I said, like, you're an actuary. You're not making rates based on, I think that this is the right rate. It's based on the data. And so, I think that you take all of these smaller models, but you're looking at things holistically, understanding how things are working, where the gaps are. And yeah, I just think that I don't know that people always take a step back. It's easier you're kind of in your niche. So I guess that's how I look at it.
I actually think that's a really interesting point because a particular challenge I think is we tend to use so many models like in concert to get to essentially one outcome, and so you can monitor each individual model, and the data is like trending the way I thought it would, and the outcomes of this model are trending the way I thought it would, but each of them just have to be a little bit different, and then collectively you can end up in like a weird place. So thinking about how not just to monitor the individual models, but also the broader outcome, I think is a really important.
I mean, we kind of have to differentiate data science between ML kind of ops, if you will, because the data scientists, I mean, you don't know the frequency of retraining. I mean, because we're kind of just doing science at that point. But for ML ops, I mean, it is, we have to, as the data flows through, we have to keep track on how that flows in the business process, and what are the results, because basically the way we look at our ML now, I mean, we've integrated this into a business process. So I'm looking at it as a circuit board, and I'm looking at our models as logic gates. So our data flows through, hits a classifier, this way, that way, goes there, hits something else. But each one of those lines came out of a subject matter expert's, thing. So we're alleviating operations of extracting data from files, selecting if this is a premium border, or doing this. We're doing that at that stage. Then we get to the next part of the business process. We need to do something else, like validate the data or transform the data. And then when we can't do that, we use the ML models for that. So it's not, shotgun approach. It's a very linear, serialized flow of business process.
And like typically like how we should monitor ML models. Like we don't know the ML. You push the ML model to production. How you know the ML model is doing good or not? You have no idea because it's basically it's going to generate its code. So things like that you have to like monitor the data shifting. Let's say like we are in a COVID and COVID is finished. Like you could not like the data is going to be shifted to something else. You have to build alert and like logs for the ML model of like stuff like to for example generate weird scores, abnormal detection models because you can have millions of logs for ML models and how you monitor all these logs. You can build like for example abnormal detection model just to monitor the logs that are generated from the ML models. If something happened, oh, the model is not doing good, I need to check it. Send me a lot, things like that. It's getting complicated when you have a model. It's really complicated when you have a model, ML model in production, and that's why only 15% of the ML models like currently in the projections. Yeah.
Philip, you mentioned having the right subject matter expert, and Eileen, I know you've been talking about like thinking for the big picture. How do you get those right set of people in the room, and like not just get them in the room for that first meeting, but get them in the room for the duration of the deployment?
I mean, hopefully people above you kind of facilitate that, but ultimately it's a lot of speaking the truth and, just, I mean, you can't go back to the old ways because we're in a new world now, and you have to work as a team. And, those initial kickoffs are a little bit challenging because everyone's coming from a different background. And, Alejandra's slide was that hammer slide, and everyone's coming with their hammer too. So it's a lot of, let's think about what we're going to do, not what you did in your past life, and then you can come together. And then you just got to have that. I mean, it's almost like informal business doing because you got to be friends almost because you're the business and you have to be friends. I mean, in order to get done.
Yeah. Well, I think like legacy systems. What about a legacy culture? Because like that's as much of a hindrance as anything from my perspective is that you have to think about like we've always done this, and yes, like when I say things in insurance, a lot of it's the same, but we can do it better. And my colleague and I were talking to someone earlier, and she's like, "Well, I hate to say this." She's like, "But the one good thing that came out of COVID is that it really did force people to change because you think insurance companies like." We'd never work from home. We'd never do, never. It's like, oh, I guess we are. We're doing it from home. We're all from home. We're all doing this. And the business of insurance can't stop. I mean, so this is not something that you could stop. So it's like, okay, so let's figure it out. Let's hold it together with duct tape. I feel very well lit now.
Yeah.
And
I was looking at the clock. I thought we were okay.
And so, but now there's a chance to look at your processes and really reimagine them and say, okay, so in this new hybrid work environment, how can we best use these technologies? How can the models make sense? And, my other point is that we've done a really good, I guess a pretty good job as an industry of automating things that were customer facing, but then like the back end's a cluster. I don't know if a cluster is a real insurance term, but it's very relatable. So, everything it's a tech term, the cluster. And so you're like, oh, I submitted this thing on my phone, or this is a very slick app. And then on the back end, everyone's running around. It's like papers and faxes and manual stuff. And you're like, God, it seems so easy to submit, but now you're not seeing.
Yeah.
Yeah.
Yeah. So maybe like going on that, what do you see as kind of the next frontier on this notion of like either ML ops or operationalizing? Those are separate questions. So let's start with just operationalizing AI. Like, what is the next frontier? Like you can't predict disruption until it's there, but like, where do you guys see the biggest potential coming from? And then maybe we'll turn like over to you guys.
I see we have a lot of supervised learning problems now that are designed by subject matter expert and technologists. I see that to be unsupervised now, driving supervised learning problems. So it's going to be unsupervised, driving supervised learning, and it's kind of originated from some data set, but it's not, that's kind of where it's at now. We're not replacing the human, but we're just making it a little bit more sophisticated. So we're taking the hunches out of the game. We might do some type of clustering analysis then, and then run the supervising on top of that. But
I think there's like lots of opportunities to utilize AI in general in insurance. Like, for example, one of the use cases is basically adjusting the rate based on the risk. And like, if today we work with real-time data, like, if I have information about this building located in this location, and there is like a fire close or fire happened before 1 week or something like that, I can adjust based on the events. So I think like with the real-time data and with the computer vision, like using and utilizing satellite images and images in general, we will have like a huge opportunity to to develop lots of productive ML models, customer generations models, predict large losses, things like that. Because if you have the data, you can really build reinforced models to predict all of that, make it really productive.
So like piggybacking on that underwriting idea. So to me, that's where there's so much opportunity for complex underwriting. We're in a hard market. There are people that have never seen a hard market before and don't understand what that means from a pricing standpoint. And so the idea of there are so many risks, when I think about the market in Florida specifically, so it's like, okay, so there were always like hurricanes, and there was this, now like buildings are collapsing. So like trying to figure out that, but then also trying to use technology, AI and machine learning to help your underwriters, not just from that standpoint, but taking things like the data in documents. And so that, it's like, well, we've automated rating forever. That is, nobody's, it's not manual rating anymore. But what about analyzing the data in loss runs? So you've got like real-time data and then other data, and using that with intelligent document processing, like that's going to help the people on the ground to make better decisions. And I think ultimately that's what you're talking about. You want to make better, faster decisions.
Throw it out to you guys. Any questions, comments? Your turn to be a part of the panel. You're just like, Julia, shut up. I want to get a drink. That's fair.
I think the analyzing documents that are part of the underwriting process, like, the whole thing about, I was talking to a client about loss runs, like complex loss runs. And so I was working internally with someone, and they asked me, they were like, well, how many different formats could loss runs be in? I was like, I don't know, how many different whatever. And so, but those are that's important data to analyze, so, the whole thing, it's like, I was like, well, okay, so just, you're like, there's, 3 years, 5 lines of business in a commercial application. It could, but bringing that data, it's making that, to me, is low-hanging fruit. On the claim side, definitely looking at different types of invoices. That's low-hanging fruit to me, because you've got like repair estimates and you've got medical invoices, and those are things that people are still going to have to analyze. Like we can do the whole straight through processing. That's fine for some things, but for complex things in insurance, to me, it all comes down. That's kind of windy, but to simple stuff versus complex stuff, and looking at the complex stuff and saying, okay, what parts can we use AI for?
You guys want to add?
Yeah, I mean, like, yeah, as I mentioned, like AI currently with Accelerant, we utilize AI to solve the data engineering problems we have. Basically, classify files, extracting data from files, and look at the like, how what kind of data we're getting from different members. We have like we work with over 60 members. We have thousands of files. So we utilize AI to enable us to scale up and dealing with all these files and map them to unified structured database core fields based in different domains. We have the finance, we have the marketing, and things like that. So I think this is like one of the biggest, use cases that we have currently at Excellent. But we are like, um, we open to like, utilize AI with underwriting. Uh, Basically, we have underwriting that supervise MGA's underwriting other teams. So what we do, we use AI, like to read their underwriting policies and basically make decisions based on that. So yeah, I think there is a huge potential for AI in insurance.
No, that's well put.
Other questions?
So I forget that we work with a lot of people, and a lot of people don't know machine learning, so they may have an idea. Oh, we do this, and can we do this model? So of course, I'm actually I'm actually a data scientist, so engineers and also data scientists, we all kind of join a call and we just say, they want this place possible and want that. So there's a lot of people that like don't know machine learning, aren't very technical, they know the underlying process. And we kind of work with them, so I kind of like know everything, but we don't know exactly what every young person is going to get. Like it's like, oh, they want to do this with the process. There's a lot of like kind of joint teams with us. They're with other data scientists. So.
I at Haven we also have a guild structure like that, and I found it hugely beneficial. Where like the data science team or the actuaries or like in some cases even the lawyers will be embedded out into product teams, and then there's still the guild or like the chapter that you come back to. So it's like, hey, I have this thing. Like let's talk about. Like, I don't know, like ASOP, like boring actuary thing, or like I'm a data scientist, and like, hey, did you read this paper? And I think that structure is kind of the best that I've experienced working in, where it's kind of a hybrid. The pure embed, you can kind of feel alone, and then when you're just a team and you kind of like go out as like a little SWAT, you kind of to Philip, to what you were saying at the beginning, like it's a little bit threatening. It's like suddenly like the data scientists come marching in, and then they like leave. And ah.
Yeah, it almost goes back to the data science 101. What is a data scientist? And they're mathematical, business, and programming. So that's the project you have to have. And if you had one of those, that's the unicorn, and unicorns don't exist. So you got to have those, hybrid teams.
Awesome. Anything else? Drinks early. Awesome. Thank you guys.
Thank you.